Hello everyone, welcome to my class. In today's class, we are going to cover general trigonometric equations and applications. So this is just a continuation of our previous class where we solved basic trigonometric equations. So now we are solving general trigonometric equations. So let's begin the class right away. First, quick preview. This section is a continuation of section 6.6. Here we solve general trigonometric equations that require slightly more sophisticated methods to work out a solution. So in addition to the basic solution method that we discussed in section 6.6, additional strategies include use of basic algebra skills and using the full range of fundamental trig identities. Once the principal root is found after applying the appropriate inverse trig functions, roots in the interval 0 to 2 pi or the general solutions can be found using the reference angles and adding the integers k multiples of the period of the functions to the root. Lastly, be sure to check all solutions of the trigonometric equations obtained in the given domain, as there may exist some extraneous solutions. Quick recall about algebra skills. Special product formula: a minus b times a plus b turns out to be a square minus b square. Other term cancel out. Perfect square formula: a plus b outside is square turns out to be a square plus 2ab plus b square. Similarly, if you have a minus sign here, then we have minus sign there. So a minus b outside is square turns out to be a square minus 2ab plus b square. Similarly, we can combine terms in fractions taking LCD. For example, a over b plus c over d turns out to be AD plus BC over BD. Here, by the way, BD is the LCD of these fractions. Similarly, if you have a minus sign here, then minus sign there, that is a over b minus c over d turns out to be AD minus BC over BD. Great. So now let's start solving general trigonometric equations. Example 1. Solve the following trig equations in the interval 0 to 2 pi. Part A. Given trig equation is sin x plus cosine x equals to radical 6 over 2. So now let's begin the solution. Now here I have a radical 6 over 2 on my right hand side. So let's square both sides. Then we have left side is sin x plus cosine x, outside is square, equals to radical 6 over 2, outside is square on my right hand side. So then on the left hand side we apply this formula here: a plus b outside is square equals to a square plus 2ab plus b square. Same as here, sin square x plus 2 times sin x cosine x plus cosine square x. And on my right side, this square cancel the radical in numerator, so only 6 left on my numerator, and on denominator 2 square is 4. I hope this computation makes sense to you all. Next, let's combine sin square x and cosine square x. Then by trig identity, that's just a 1 plus 2 sin x cosine x as it is, equals to, on right hand side, let's cancel by 2 to 3 times 6 to 2 times 4, so 3/2. Next, let's isolate sin x cosine x terms alone on left hand side. So subtract 1 from both sides. Then we have 2 sin x cosine x equals to 3/2 minus 1. And we know 2 sin x cosine x is another trig identity, which is sine of 2x. That's a double angle formula, equals to 3/2 minus 1 is 1/2. Then apply the sine inverse both sides on this last equations. Then we will have 2x equals to sine inverse 1/2. Since we are solving sine 2x equals to 1/2, means sine 2x is positive on first quadrant and second quadrant, so we are looking for angle on those respective quadrants. So sine inverse 1/2 is pi over 6 in first quadrant and 5 pi over 6 in second quadrant. Then solve for x equals to then pi over 12 and x equals to 5 pi over 12. Great. So now our goal is to find the root in the interval 0 to 2 pi. Now let's ask questions to ourselves. Are there any other solutions besides those pi over 12 and 5 pi over 12 in this interval 0 to 2 pi? By the way, the period of sine 2x is just pi. So then, if there are other solutions in this interval 0 to pi, then those solutions are pi over 12, let me go this way, pi over 12 plus integer times the period. Similarly, 5 pi over 12 plus integer times the period. Now, let's check what are the possible values of k. If k is 1, then another solution is 13 pi over 12. This still lies on 0 to 2 pi. In here, if k is 1, then another solution is 17 pi over 12. Still lies in 0 to 2 pi. If k is 2, then from the first relations, it turns out that another solution is 375 degree, but this lies outside our 0 to 2 pi interval, so this is the extraneous solution. Similarly, if k is 2, then from the second relations here, another solution turns out to be 435 degree, which is again outside our 0 to 2 pi intervals. So we have only total 4 solutions in 0 to 2 pi intervals. One is pi over 12, another 5 pi over 12, another 13 pi over 12, and another 17 pi over 12. So these are our solutions of given trig equations in the interval 0 to 2 pi. I hope this makes sense to you all. Now let me visualize here. So here, what I graph here, I graphed sine 2x. This is the green one, and this red is the regular sine functions graph. Since our angle is multiplied by the constant, that shrinked our sine curve. So this green is the graph of sine 2x. And another line I graph y equals to 1/2 because we are solving, let me show you here, we are solving sine 2x equals to 1/2. So I graph two functions, y equals to sine 2x and y equals to 1/2, and see the intersection point. So here, then I found the intersection point here, 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 and here. So total we have 4 solutions in the interval of 0 to 2 pi. I hope this graph makes sense to you all. Great. So we verified our solutions by graphing. Let's move on. Part B. Solve the general trigonometric equations 4 times sine x cosine x minus 2 radical 3 sine x minus 2 cosine x plus radical 3 equals to 0. Begin the solutions. Let's factor by grouping. First to one group and third and fourth second group. From the first group, factor 2 sine x out, 2 cosine x minus radical 3 left. From the second group, take 1 out, 2 cosine x minus radical 3 left. So then inside the parenthesis, 2 cosine x minus radical 3 out, then left 2 sine x minus 1, another factor. Since the product of two factors equals to 0 implies either one should be 0, so from the first 2 cosine x minus radical 3 equals to 0, or second factor equals to 0 from the first factor equals to 0 gives us here cosine x equals to radical 3 over 2. Take this radical 3 to the right side and divide by 2. Then here the cosine x is positive in first quadrant and in fourth quadrant. So from here x equals to then cosine inverse radical 3 over 2. So then one angle is pi over 6, another angle is 11 pi over 6 in the fourth quadrant. Similarly, from the second factor, 2 sine x minus 1 equals to 0. Sine x equals to 1/2. Take 1 to the right side and divide by 2. Since sine x is positive in first quadrant and second quadrant, so in first quadrant it gives us x equals to pi over 6, and in the second quadrant it gives x equals to 5 pi over 6. So now we have 4 angles. One is pi over 6, 11 pi over 6, pi over 6, these two are repeated, and 5 pi over 6. So then our solutions are x equals to pi over 6, I just pick one out of those two, and 5 pi over 6 and 11 pi over 6. Since for the sine function period is 2 pi, are there any other solutions in 0 to 2 pi? So let's add 2 pi to this angle pi over 6. It gives us the angle outside the 2 pi. So this is the next term of solutions. Hence we have 3 solutions. So let me verify the solutions by graphing. So here, what I graphed here, I graphed sine x, the green one, and the pink one is cosine x, and we are solving sine x equals to 1/2. This is the 1/2 graph. So the solutions between 0 to 2 pi are here and here. And another, we are solving cosine functions, and another one is, let me see here, is a radical 3 over 2. Another line is y equals to radical 3 over 2, this blue one. Then the solutions our intersection point are here and here. So total we have 4. These 2 common, so just take 1, then 2, and then 3, which are here. And the pi over 6 was repeated. Awesome. I hope it makes sense to you all. Now let's move on. Part C. Solve 2 times cosine square x over 3 plus 3 sine x over 3 minus 3 equals to 0. Looks a bunch of 3's there. Now let's begin the solutions. First, convert cosine square equals to 1 minus sine square. Copy other terms as it is. Next, foil these 2 inside. So here's what I did. I send this 2 inside and add and subtract, and I want to start from sine square. So I again factor the minus 1 out and send toward the right hand side. So I have this one here. So I did little bit algebra here. I hope it makes sense to everyone. Then think this one as a quadratic equations, like 2a square minus 3a plus 1 equals to 0. Then we can easily factor the quadratic equations. So now here I factor. This is 2 times sine x over 3 minus 1. Another factor, sine x over 3 minus 1. And this equals to 0. Then again, either the first factor equals to 0 or second factor equals to 0. From the first factor equals to 0 gives us x over 3 equals to sine inverse 1 over 2. Since sine function is positive in first quadrant and second quadrant, so we are looking for angle in first and second quadrant. So then x over 3 gives us pi over 6. So solve for x equals to pi over 2, and x over 3 equals to 5 pi over 6. This is the angle in second quadrant, but solve for x gives us x equals to 5 pi over 2, but this lies outside the 2 pi. By second factor, our second factor is sine x over 3 minus 1 equals to 0. Here. So that means sine x over 3 equals to 1. So x over 3 equals to sine inverse 1. since sine x over 3 is 1, this is positive. This is in the first quadrant and second quadrant, but sine inverse 1 is pi half, and that's in the first quadrant, because sine inverse, its range is minus pi over 2 to plus pi over 2. Then solve for x equals to 3 pi over 2. Awesome. So thus the required solutions are, one is pi over 2, another one is 3 pi over 2, since this solution lies outside the 2 pi. So now let me verify these two solutions in the graph. So here, this is the green one, is our sine x over 3. Keep in mind the blue one is just a regular sine functions graph, but we are dividing the angle by 3. That means we are stretching out our sine graph. So then this green is our stretched sine graph, and we are solving sine x over 3 equals to 1. So another line is y equals to 1. So this line, and another one we are solving, let me say, sine x over 3 equals to 1 half. So another line is y equals to 1 half. Then I need to look for the intersection of sine x over 3 graph with y equals to 1 and 1 half. So one solution is here, one solution is here. That's it, because I'm looking for solutions in between 0 to 2 pi. So I have two solutions, which are this one here. I hope it makes sense to you all. Awesome. Now let's move on. Example 2. State the period of the following trigonometric functions and find all solutions in the interval 0, p. P is the period. So first let's find the period. So given question is 1235 times cosine of angle. The angle is pi x over 12 minus pi fourth, outside minus 978 equals to 0. Now let's begin the solutions. First find the period. By formula, period equals to 2 pi over b. B is pi over 12. Pi cancel, you flip the 12, then 12 times 2 is 24. So period is 24. So we are looking for solution of this given trig equations in the interval 0 to 24. I hope this idea makes sense to you all. Next, let's divide both sides by 1235 and bring 978 to the right side. So we will have this one here. So cosine of this angle equals to 978 over 1235. This fraction is 0.7919. Since we are solving cosine of this angle equals to the positive number, so cosine is positive in first quadrant and fourth quadrant. So here, for simplicity, let's assume this angle in fraction form equals to u. Then this given equations becomes cosine u equals to 0.7919. Solve for u means multiply both sides by cosine inverse. This gives me cosine inverse 0.7919 equals to u. So u equals to approximately then 0.6569. This is in first quadrant. So here u equals to, let's resubstitute the variables, pi over 12x minus pi fourth, approximately 0.6569. Then let's solve for x. So add pi over 4 both sides, which I did here. Next, this sum is approximately 1.4423. To find the value of x, multiply by its reciprocal, that means 12 over pi times this number on my right side, approximately x equals to then 5.5092. That's the solutions. So next, in fourth quadrant, this u equals to cosine inverse 0.7919 in first quadrant. Now in fourth quadrant, u equals to minus cosine inverse 0.7919, which I wrote here. And by the way, u is pi over 12x minus pi fourth. I hope this expression makes sense to you all. Then this cosine inverse we already computed here, 0.6569. Then solve for x. So add pi over 4. It's approximately right hand side turns out to be 0.1285. And multiply by 12, divide by pi, then x equals to approximately 0.4909. Hence there are two solutions. One is x equals to 0.4909, another one is 5.5092. Since another solution we cannot find because the period is, what's our period? Period is 24. If we add 24 over those roots, it goes outside the 24. Great. So now let me visualize. So here the purple graph is the graph of cosine of angle pi over 12x minus pi fourth, and this red color line, this is the y equals to 0.7919. So between 0 to 24 here they intersect at these two locations where x equals to 0.4909 and another x equals to 5.5092, and another one is after 24, which you don't care. I hope this makes sense to you all. Now let's move on. Example 3. Using any appropriate method, solve cosecant square x minus cotangent x minus 1 equals to 0. Begin the solutions. First convert cosecant square x in terms of cotangent. So the formula is cosecant square x equals to cotangent square x plus 1, then minus cot x minus 1. I copied as it is. Then this 1 and minus 1 cancel, so we have cot square x minus cot x equals to 0. Factor the cot x, factor the cot x, then we have cot x left here, minus 1 left, and to the right side 0. So again, the product of these two factors equals to 0 implies each of the factors equals to 0. So first cot x equals to 0, and in second cot x minus 1 equals to 0. Since both are positive values here, so the cot x is positive on first quadrant and third quadrant. So from the first, cot x equals to 0 gives us x equals to pi over 2 in the first quadrant, and in the third quadrant, which is 3 pi over 2. And from cot x minus 1 equals to 0, cot x equals to 1 implies x equals to pi fourth in first quadrant and in 5 pi over 4 in third quadrant. I hope it makes sense to you all. Then the general solutions, because the questions here ask us to solve, means we need to find out the general solution. So for the general solutions, we need to add the period times the integer to the root. So here period is pi, by the way, for the cotangent functions period is pi. So I'm adding pi times integer k to pi fourth and pi times integer k to pi over 2. Great. So now let me verify these solutions in 0 to 2 pi interval. So this is the cotangent x graph. They are vertical asymptote at pi, at 2 pi, and so on. Same as to the negative side. But between 0 to 2 pi, I am solving cot x equals to 1 and cot x equals 0. So that means this is y equals to 0 line, this is y equals to x line. So between 0 to 2 pi, this is one intersection point, this is another, this is another, and this is another. So total 4. That's the 4 we already found here. Pi fourth, pi half, 3 pi over 2, and 5 pi over 4. And if we continue to this side, we have other real solutions also, which gives by this pi k. I hope it makes sense to you all. Now let's move on. Example 4, let's talk about the application of trig equations. Reverse discharge rate problems for June through February. The discharge rate in cubic meter per second of Lake River can be modeled by this trigonometric equations, where T represents the month of the year with a T equals to 1 corresponding to June. So the question is, A, what is the discharge rate in mid-September? So in mid-September means from June. So June, July, August, September. So June 1, July 2, August 3, September 4, mid-September means 4.5. So we need to solve these equations for T equals to 4.5 to find the answer for part A. For part B, for what month of the year is the discharge rate is over 50 cubic meter per second? Great. So now let's begin the solutions. Begin the solutions. By the way, the period it turned out to be 8. So just use the formula. P equals to 2 pi over 4. Then you cancel the pi and you flip the 4. 4 times 2 is 8. And for month June through mid-September, T turned out to be 4.5. So simply plug T equals to 4.5 to answer the part A. So I put T equals to 4.5 and solve. So using calculator, it gives us approximately 78.53 cubic meter per second. Now part B, for what month of the year is the discharge rate over 50? So let's solve 50 equals to, I need to find the value of T from these equations. So here is 36 sine of angle pi 4th T minus 9/4 plus 44. Let me scroll down this way. That's better. Then what I did next here. So the next I subtract 44 from both sides. Then we have 36 sine of angle pi 4th T minus 9/4 equals to 50 minus 44 is 6. Next I divided both sides by 36. Then we have sine of angle pi 4th T minus 9/4 equals to 6 over 36. This implies 1 over 6. Since we are solving, sine of angle is positive, that means we are finding the angle in first quadrant and second quadrant where sine is positive. So now again our angle is in the fraction form here, so let's put u equals to this fraction form angles here. So let's u equals to pi 4th T minus 9/4. Then this equation reduces to u means this angle equals to sine inverse 1 over 6, which is approximately 0.1674. This is in first quadrant. In second quadrant, so simply subtract from pi, which turns out to be 2.9741, because in first and second quadrant sine is positive. So hence let's resubstitute the u in terms of t variable. So this is the u, approximately 0.1674. So solve for t, that means add 9/4 both sides and multiply both sides by 4 over pi. It turns out that t equals to approximately 3.0779. So that means June is 1, July is 2, August is 3. So in August the discharge rate is 50 and over. Similarly, from this second part here, so pi over 4 times t minus 9/4, approximately 2.9741. That's better. And solve for t, that means add 9/4 both sides and divide both sides by pi over 4. Then it gives us, this is sine algebra here, t equals to approximately 6.6165, which means mid-November. So for August through mid-November, the discharge rate is over 50 cubic meter per second. Great. So now let me visualize our computations here. So this is the given trigonometric functions graph. this one, and this is y equals to 50, and another one is y equals to 78.5. So here is in part A, we solve when t equals to 4.5. Our output is 78.53, which verifies here 4.5. This is 78.5. Yeah, that's approximately. Yeah. Similarly, we found for discharge rate is over 50 at 3.07 and at 6.61. So that means here. So this is 50. So here 3 point something and 6.6 something here. So then this part, that means from August to mid-November, the discharge rate is over 50 cubic meter per second. Great. I hope it makes sense to you all. We finish these sections as well as we finish chapter 6. So in next class we will start chapter 7. Thank you.